When drilling an oil well, it is important to control water loss from the drilling fluid for several reasons. 1. Wellbore stability. Water loss can lead to a decrease in the drilling fluid volume and an increase in the concentration of solids in the fluid. This can result in a loss of support for the wellbore, potentially leading to instability, collapse, or stuck pipe. Controlling water loss helps maintain the integrity and stability of the wellbore, ensuring safe drilling operations. 2. Formation damage prevention. Water loss can cause the invasion of drilling fluids into the surrounding rock formations. This invasion can result in formation damage, where the drilling fluids block the natural flow paths within the reservoir and reduce the permeability of the rock. Formation damage can hinder the production of oil or gas from the reservoir, leading to decreased productivity and increased operational costs. 3. Lost circulation prevention. Excessive water loss can lead to lost circulation, which occurs when drilling fluid is lost into highly permeable formations or fractures instead of circulating back to the surface. Lost circulation can cause significant operational challenges, including reduced drilling efficiency, increased costs due to fluid loss, and potential well control issues. 4. Mud properties maintenance. The drilling fluid, often called mud, is engineered to have specific properties that aid in the drilling process, such as carrying cuttings to the surface, providing lubrication, cooling the drill bit, and exerting hydrostatic pressure to control formation fluids. Excessive water loss can alter the desired properties of the mud, reducing its effectiveness in performing these functions. By controlling water loss, the mud properties can be maintained within the desired range, ensuring efficient drilling operations. 5. Formation evaluation. The purpose of open-hole logging is to evaluate the virgin formation, the formation that is in situ, the formation that has not been invaded by drilling fluid loss. When high fluid loss occurs, because of the limited depth of investigation of logging tools, investigation of the virgin zone might be impossible. To control water loss during drilling, various techniques are employed, such as the use of additives and viscosifiers to improve fluid properties, optimizing mud weight and rheology, and implementing appropriate drilling practices to minimize fluid invasion into the formation. These measures help ensure successful drilling operations while minimizing risks and maximizing well productivity. An API filter press test is run when drilling an oil or gas well to measure fluid loss in water-based drilling fluids. The filtration and wall-building characteristics of mud are determined by means of a filter press. Essentially, the filter press consists of a cylindrical mud cell with an inside diameter of 3 inches and a height of 2.5 inches or greater. The drilling fluid chamber is made of materials resistant to strongly alkaline solutions and is so fitted that a pressure medium can be conveniently admitted into and bled from the top. The design is also such that a sheet of 9-centimeter filter paper can be placed in the bottom of the chamber just above a suitable support. Thus, the filtration area is 7.1 plus or minus 0.1 square inches. Below the support is a drain tube for discharging the filtrate into a graduated cylinder. Sealing is accomplished by gasket. To use the filter press, be sure each part of the cell is clean and dry and that the gaskets are not distorted or worn. Pour the sample of mud into the cell and complete the assembly. Then place the dry graduated cylinder under the drain tube to receive the filtrate, close the relief valve, and adjust the regulator so that the pressure equals 100 plus or minus 5 pounds per square inch. At the end of 30 minutes, measure the volume of filtrate. Shut off the flow through the pressure regulator and open the relief valve carefully. It may be desirable to use a 1-hour filtrate test for oil-based muds. The time interval, if other than 30 minutes, shall be reported. Report the volume of filtrate in milliliters, as the API filtrate report. Round your answer to 0.1 milliliter. Report at the start of the test the mud temperature in degrees Fahrenheit. At the end of 30 minutes, remove the cell from the frame, first making certain that all pressure has been relieved. Then disassemble the cell, discard the mud, and use extreme care to save the filter paper with a minimum of disturbance to the cake. Wash the filter cake on the paper with a gentle stream of water and with diesel oil in the case of oil-based muds. Measure the thickness of the filter cake. Report the thickness of the filter cake in 30/2 of an inch. Although standard descriptions are virtually impossible, such notations as hard, soft, tough, rubbery, and firm might convey some idea of cake consistency. In summary, when drilling an oil well, it is important to control water loss from the drilling fluid for several reasons. 1. Wellbore stability. 2. Formation damage prevention. 3. Loss circulation prevention. 4. Mud properties maintenance. 5. For formation evaluation purposes. To control water loss during drilling, various techniques are employed, such as the use of additives and viscosifiers to improve fluid properties, optimizing mud weight and rheology, and implementing appropriate drilling practices to minimize fluid invasion into the formation. These measures help ensure successful drilling operations while minimizing risks and maximizing well productivity.